So you are saying MCQ number 7, correct? Anything before that? Anyone else? Anyone in the lecture? Anyone? Any other question from 1 to 6? Yes, anyone? If not, then we can start with the 7th one directly. Okay then, so let us start. The value of the integral dz upon z cube z plus raised to 4, ये पावर में कुछ है कि कॉमा है? It seems just z plus, yeah, it is just a comma, na? Okay. Where C is the circle, mod of z plus 2 equal to 3 taken in the counterclock. That's okay, we'll do that. Mod of z plus 2 equal to 3, correct? Do you see what are the problems, what are the singularities for this? Z equal to 0, correct. Let us see which of them lie inside the contour. So z plus 2 equal to 3, how to draw this? Where is the center? Correct. So minus 2 comma 0, so here it is, and radius 3 will be 2 minus 3 minus 4 minus 5. So ये minus 5 तक जाएगा ना, 3 unit. So here it will go here, and यहाँ पे minus, यहाँ पे just 1 unit, ऐसा कुछ, something like that. Am I correct? Yes. Now z equal to 0, it is lying inside my contour. What is next guy? Z equal to minus 4, this is also lying inside the contour, correct? So both of them are lying inside the contour. How will you do? How will you solve this? What is the Cauchy integral formula? Cauchy integral formula you can solve only if your question is something like 1 upon z minus e raised to n, correct? Some phi of z. Then only you can apply Cauchy integral formula. But there are both two singularities in the domain in your contour. So here the best thing is used to, you can use Cauchy residue theorem here, correct? Otherwise also you can do, you just have to separate them, 1 upon z cube and 1 upon z plus 4. You need to separate them, and then also you can do, or best way is to use Cauchy residue theorem. Can you calculate residue at z equal to minus 4? How will you calculate residue at z equal to minus 4? First of all, you have to write your function in that form. That is contour. This will be dz upon z cube, the whole upon z plus 4, correct? The numerator is analytic function at z equal to minus 4, so it is not a problem for me. So what is residue? You can write it as integral f of z. Residue of f of z at z equal to minus 4, it will be what? Can somebody tell me what is the residue? It is simple pole, correct? Power is 1, so it is just simple pole. So what is the residue? It is just phi of z naught, correct? और phi of minus 4 लिखता हूँ मैं. phi of minus 4 क्या आएगा ये phi of minus 4? 1 upon minus 4 का cube, so it will be minus 1 upon 4 का cube. That's it. ये हो गया इसका रेसिडियो. What next? समझा क्या? इतना क्लियर है? Shall we go ahead? Is that clear to you? Do you understand मैं कौन सा theorem use कर रहा हूँ to calculate the residue? I'm using this. If you can write your function phi of z upon z minus z naught raised to n plus 1, then residue will be what? Yes, phi of n n, actually यहाँ पे n plus 1 लिया ना, so phi nth derivative of z naught upon n factorial. This is the formula for residue. So in the second case, for z equal to 0, you again have to write your function properly. For z equal to 0, what is the function? Dz upon, so you have to write it as integral dz upon z plus 4 the whole upon z cube, correct? So this is again of the form phi of z dz upon z cube. So residue क्या आएगा? Residue of function at z equal to 0, it will be what? Phi power 3 ना, तो phi 2 second derivative at 0 upon 2 factorial, correct? So you have to find second derivative first. So 1 upon z plus 4 है ना वो, so phi dash क्या आएगा? 1 upon x का minus 1 upon x का, so it will be minus z plus 4 the whole square. Again phi double dash क्या आएगा? It will be a minus minus plus, it will be 2 times 2 upon z plus 4 the whole cube शायद, minus n minus 1, yes correct. तो अपने को क्या चाहिए? 0 चाहिए, तो 0 पुट कर दो इसमें, ये क्या आएगा? ये this will be 2 upon 4 cube, that is your final answer, 2 upon 4 cube, correct? So by Cauchy residue theorem, what do we know? By Cauchy residue theorem, we know that integral whatever it was, that is dz upon z cube and z plus 4, it is equal to 2 pi I residue at z equal to 0 plus residue at z equal to minus 4, correct? So it is 2 pi I multiplied by residue at z equal to 0, it is किधर गया? 2 upon 4 cube, so it is 2 upon 4 cube, and a residue at z equal to minus 4, it is minus 1 upon 4 cube, so it is minus 1 upon 4 cube. So क्या आएगा ये? 2, yes, yeah, yes. So it will be 2 factorial will be here only, na? Correct. Thank you. And here it will be 2 factorial. So 2 and 2 is cancelled then. We are getting 0 as the answer, correct? So answer will be 0. Which option? Is that clear to you everyone? Yes? I'm just calculating why residue is helpful for me here. Because here do you see z cube is there and z plus 4, 2 this is not a simple pole. If it was a simple pole at z equal to 0, then it was quite easy, correct? So which option? Option number B, na? Option B, yes. Z equal at B equal to 0. Okay. Any other question from this 1 to 8? From question number 1 to 8, any other? See, I am not telling that we cannot solve this by using Cauchy integral. We can do that also, but it will be quite lengthy. You just have to break this 1 upon z cube and 1 upon z plus 4. You have to break it. Then you have to do. Answer will be same. Cauchy residue seems good to me, so I used to use it all the time. What next? Should I go ahead or any other question? 12, 9, 10, 11, 12. ओके 12 का क्या दिया है, ये क्या लिखेगा? आई एन इक्वल टू इंटीग्रल जेड माइनस ई रेज टू एन. हाँ या दिस इज अ सिंपल प्रॉब्लम. हाँ ये आई थिंक थ्योरम भी था ऐसा एक, सो विल डू दैट. So integral it was z minus e raised to n ना, यही है ना, over the contour. क्या था क्वेश्चन? This is called I n raised to n over mod of z minus e equal to r. I n mod of z minus e equal to r. It is quite easy question actually. You have to decide by seeing the value of n. एंड इफ़ यू सी ऑप्शन में n का वैल्यू के बारे में ही बात किया है. ऑप्शन इट इज़ 0 फॉर ऑल n, इट इज़ 2 पाई आई फॉर ऑल n, आई एन इज़ 0 फॉर ऑल n नॉट इक्वल टू -1 एंड आई -1. सो डू यू सी -1 पे थोड़ा इनको इशू हो रहा है ना, तो लेट अस सी -1 पे क्या प्रॉब्लम है भाई. व्हाट अबाउट इफ n इज -1 फॉर n इक्वल टू -1. करेक्ट. व्हाट विल बी दिस? This will be in equal to integral 1 upon z minus e, correct? In this contour. Can I use my Cauchy integral formula? Z equal to a is my singularity and it is in the contour. Do you see what is the answer? Yes, what is the answer? It is 2 pi I into f of 1 na, so that is function is ऊपर का 1, so it will be 2 pi I into 1, correct? Cauchy integral formula, I hope you remember. Is that okay? What is the formula for Cauchy integral? That is if you are having say phi z बोलो या f of z बोलो, f of z upon z minus e raised to n plus 1. So this is equal to f nth derivative, actually 2 pi I. It is 2 pi I into f nth derivative at z at e upon n factorial. That's it. So in this case, your function is f of z is 1. Correct? So 2 pi I it will be function at 0, function at e, but function तो constant है. So answer is 2 pi I. Is that clear? So it is for I minus 1. Is that okay to you? और अगर if you don't like Cauchy integral formula, actually if you remember जो first integral मैंने solve किया था यही किया था. I don't know whether you remember or not. और हम लोगों ने कैसे solve किया था ऐसे. We were not aware about Cauchy integral formula at that time. So what is my contour? Mod of z minus a equal to r. So I consider it as let parameterize किया मैंने. Z minus a equal to r e raised to I theta. Then what will be dz? Dz will be r theta e raised to, ri e raised to I theta d theta. Correct? And then if you put it here, it will become now 0 to 2 pi and dz will be this ri e raised to I theta and divided by what? Divided by z minus a ना, that is r e raised to I theta. If you remember, start में सबसे पहले मैंने यही सिखाया था तुम लोग को. r e raised to I theta is cancelled. It is 0 to 2 pi and I d theta actually. So it is 2 pi I. From here also you are getting the same. Correct? Yes. Can somebody tell me what if your n is not equal to 1? if n is not equal to -1, what can you say? And if I'm talking about all the natural numbers, suppose in equal to z minus e raised to n over that contour. See, I need to all the time look at the MCQ. See, there are so many options. कहाँ पे है? फर्स्ट ऑप्शन में n इज इंटीजर, ओके. ऑप्शंस देखते हैं. ऑप्शन ई कहाँ पे है भाई? हाँ, ऑप्शन ए, इट इज 0 फॉर ऑल n. सो ऑप्शन ए रॉन्ग है, दिख रहा है. व्हाट अबाउट ऑप्शन बी? इट इज 2 पाई आई फॉर ऑल n. वी डोंट नो, वी जस्ट नो कि -1 पे 2 पाई आई है. दैट इज द वन थिंग वी नो. सी इज आई एन इज 0 फॉर ऑल for n not equal to -1, and otherwise it is for -1 it is 12. So it is seems to be good one, and option D तो wrong है because I -1 हम लोगों ने निकाला 0 है. so option C दिख रहा है. ठीक है, मतलब अगर MCQ टिक करना होता तो ऑप्शन C is the perfect one because others are not true. The first question, in the first one it was saying 0 for all n, in the second it was saying it is 2 pi I for all n, and in the third one it was satisfying one of the 40, but we have not proved that in is 0. We will do that. And D is already not true, that is I -1 is 0. So do you see option C is correct one? Now you have to prove in is 0. How can you do? You have to prove in is 0. Can somebody quickly tell me? It is very easy, and if you see it is just Cauchy integral formula देखा तभी भी दिखेगा तुमको, और डायरेक्टली बोला तभी भी दिखा. Suppose n is not equal to -1. So let us take two cases. Suppose n is integer है ना, तो suppose n is less than -1. So it will be something like this. Correct? मतलब ये n का पावर क्या रहेगा? -2, -3 और एनीथिंग. डू यू सी दिस इज 0 बाय कॉशी इंटीग्रल फॉर्मूला. इफ इट इज -2 तो मुझे क्या करना रहेगा? फंक्शन का डेरिवेटिव लेना रहेगा. डू यू सी द डेफिनेशन ऑफ कॉशी इंटीग्रल फॉर्मूला? इफ यहाँ पे अगर 2 है, इफ दिस इज 2, तो इसका एक बार डेरिवेटिव लेना पड़ेगा. n+1 तो n. क्लियरली? सो इफ इट इज 2, इफ दिस n is 2, then what? This is -n actually. This is not n, -n, because वो लोग ने लिखा क्या है? z minus e raised to n लिखा है. This is the question ना. So अगर 1 upon में लिखा तो it will be 1 upon z minus e raised to -n. Is that clear to you? So if n is less than -1, so -n is less than 2, less than 1. -1 is greater than, -n is greater than 1. What do you mean by greater than 1? So -n can be 2, 3, 4 and so on. But if it is 2, 3, 4, तो ऊपर वाले को तो डेरिवेटिव लेना पड़ता है ना, तो वो क्या है? कांस्टेंट फंक्शन है. So it is 0. Is that clear to you? It was a simple Cauchy integral, डायरेक्ट दिख रहा था. Yes. What if your n is greater than -1? N is greater than -1 means what? N can be 0, 1, 2, 3 and so on. So your question will be C, z minus e raised to n. Can somebody tell me in this case, do you have any problem for this? This is analytic in the contour, and by Cauchy theorem क्या बोलता है? Cauchy-Gorsat theorem बोलो. Cauchy-Gorsat theorem क्या बोलता है? If your function is analytic in that contour, then it is 0. तो कुछ प्रॉब्लम ही नहीं है करने में. This is by Cauchy-Gorsat theorem. I hope तुम लोग को याद है Cauchy-Gorsat theorem. We have done some example based on that. Is that okay to you? So हम लोगों ने प्रूफ क्या किया? For -1 it is 2 pi I, and for other people it is 0. So option number C. वो डायरेक्ट भी दिख रहा था, हम लोगों ने -1 निकाल लिया था. Okay, and Jamin, you are saying 13 also ना? Okay, what is 13? Contours, this is sin z dz, equal to I, where C is any Jordan curve in the complex plane. Tell me, what can you say? What is the answer? Can you actually just मैंने 12th में use कर लिया. In question number 12 I use this. What do you know about sin Z? Yes. Do you have any singularity for sin Z? What do you know about sin Z? Whether it is analytic. So what is the answer? My Cauchy Gorsat theorem 0 आएगा. Correct. कुछ प्रॉब्लम ही नहीं था ना इसमें. There is no pole, nothing. Just I need to check it. हाँ, perfect. Good. If you wanted to confirm, then that is very nice. Okay, what next? Anything else here? 14, 15, 16, 17 or anything before that? Anybody else? Oh, 17 में. अरे जो आंसर है वही डाल दो और क्या भी. इंटीग्रल cos z अपॉन z इंटू. हाँ सिंपल है, जस्ट सॉल्व कर लो. सी यू डोंट हैव टू सी. यहाँ पे भी जस्ट कंटूर इज नॉट अ सर्कल, सो नो इशू हियर ऑल्सो. समझ रहे हैं? करना तुमको वही है. यू जस्ट हैव टू सी कि तुम्हारा जो पोल्स है वेदर दे आर लाइंग इनसाइड दैट कंटूर और नॉट. आई डोंट केयर वेदर माई कंटूर इज सर्कल और रेक्टेंगल और एनीथिंग. It can be any figure, I don't care. I just have to see whether my poles are lying inside. If it is lying inside, I will directly use Cauchy integral formula, that's it. समझा तुम लोग को? Because in all the cases we are always taking the circle or disc for the contour, but here you are having this as the contour. But mind it, there is no problem if you take any contour. It can be in general any contour containing if the poles ऐसा poles है तो you can do that. And how will you to solve this question? How will you do? Z into z square plus 8. Z square plus 8 means what? It will be 2 root 2 na? Something 2 root 2 I. Correct? That is. हाँ सिर्फ जीरो ये लाइक रहे तो वो तो और इजी हो गया. फिर जस्ट cos 0 अपॉन ये cos 0 क्या होता है? 1/8 आएगा आंसर. फिर 2 pi I into 1/8, that is pi I upon 4. करेक्ट. सो यू कैन पुट सम ऑप्शन pi I upon 4, pi I upon 8, 2 pi I, ऐसा मतलब एक बना लो. योर ऑप्शन इज करेक्ट. यस. Is that clear? So it is quite easy if you know the contour, if you know the theorem. Cauchy Gorsat theorem पता रहना चाहिए, Cauchy integral theorem पता रहना चाहिए, Cauchy residue theorem पता रहना चाहिए. And you should know कि how can you calculate residue, how can you calculate residue of a pole. Yes. Anything else? बाकी सब तो easy दिख रहा है मुझे. बोलो अगर तुम लोग को आगे भी कुछ है क्या? नहीं, इधर ही तक है. ये सब क्वेश्चन मस्त है. हाँ अलॉन्ग करना है मतलब यू हैव टू जस्ट टेक पैरामीटर. जैसे तुम लाइन इंटीग्रल सॉल्व करते थे ना अपना, सेम वही है ये. अलॉन्ग द लाइन z इक्वल टू 0 टू z इक्वल टू 1 प्लस आई. सो z इक्वल टू 0 टू z इक्वल टू 1 प्लस आई, दैट मीन्स व्हाट? फ्रॉम 0 0 टू 1 1. सो व्हाट विल बी द पैरामीटराइजेशन? From 0 0 to 1 1. Can I take my parameterization as z equal to t plus ti, where t is between 0 to 1? So if I put t equal to 0, it will be 0. If I put t equal to 1, it will be 1 plus I. So your parameterization is z equal to t plus ti. पुट करो इसमें खत्म. रियल की जगह पे टी ब्रो, एक्स की जगह पे टी, वाई की जगह पे डी बी टी, एंड दैट्स इट. See here is the question. Evaluate this integral. So by looking at n you have to decide कि क्या क्या रहेगा. वही मैं बोल रहा हूँ कि ऐसा मतलब एक क्वेश्चन थ्योरम था जो एमसीक्यू में अभी किया हम लोगों ने. बाकी तो सिंपल है. इवेल्युएट दिस अपर हाफ लोअर, ये सब एक्चुअली स्टार्टिंग में हम लोगों ने किया है. बहुत इजी क्वेश्चन है ये. फिर इधर से कॉशी इंटीग्रल स्टार्ट हो जाता है. Yes. Any other question or shall we move to the next practical? ये क्वेश्चन मस्त है. फाइंड इमेज ऑफ गिवन सेट. You have to find the image of this w equal to 1 upon mod z equal to 8 है. So if you calculate w 1 upon z, so what will be mod z equal to 8 का इमेज क्या आएगा? Whether it is again a circle, whether it is क्या आएगा, you just have to decide after solving. So करने का क्या, w को सॉल्व करने का 1 upon z, 1 upon z that means 1 upon x plus i y, numerator and denominator multiply by x minus i y. Then if your mod z equal to 8, put some values and observe what about mod w. Actually mod w will be 1 upon z, 1 upon mod z. That is again it maps circle to circle. Okay, construct a linear fractional transformation. I have already given you a formula for if you are having 0 map to -1 I. क्या फॉर्मूला था, याद है तुम लोग को? It was, I'll write it here if you, z minus z1 into z2 minus z3 upon z minus z3 into z2 minus z1. 1 2 3 3 2 1 याद रखने का ऐसे. सेम ईयर w माइनस w1 into w2 minus w3, and here it will be w minus w3 into w2 minus w1. That's it. Correct? Okay. ये हो गया. What else? Determine whether each of the following set of points lie on a circle. How will you calculate whether the points lie on a circle or not? Should lie on a circle, they are saying. Actually there is a trick. If your Mobius transformation जो हम लोगों ने वैल्यू बताया ना, z minus z1 और ये तो maybe I remember or not. Just let me see. 0 minus 4 minus 2i, 0 minus 4 minus 2i, and minus 1 minus 3i, minus 1 minus 3i. So you just find this part, that is z minus z1. इसमें z की जगह पे z4 पुट कर दो. So I'll find this z4 minus z1 into z2 minus z3 and divided by this will be z4 minus z3 into z2 minus z1. Put the value and see what you are getting. z4 minus z1, z4 मतलब ये, z1 is this, so it will be just minus 1 minus 3i, z2 minus z3, so z2 minus z3 मतलब ये दोनों का subtraction ना, it will be minus 4 plus 2i, and it is divided by z4 minus z3, z4 minus z3, so it will be plus 2i ना, so minus 1 minus I. it will be minus 1 minus I and multiply by z2 minus z1. Z2 minus z1, so it is minus 4, correct? So it is something like कुछ तो condition है, let me just be sure. Yes, whether question number 8. So you just have to check whether that cross ratio must be real, which I just wrote. If this z4 minus z1 into z2 minus z3 upon z4 minus z3, so this is 1 2 3 3 2 1, यहाँ पे z4 z1 is real, then the four complex number are consecutive. Four complex number A, z1 z2 z3 and z4, they are consecutive. मूवीज ट्रांसफॉर्मेशन का एप्लीकेशन था ये. ओके, ये हो गया. व्हाट नेक्स्ट? यू कैन कंस्ट्रक्ट दैट. ये तो ठीक है बाय पुटिंग इट देयर. एनीथिंग एल्स? या शैल वी गो टू द नेक्स्ट प्रैक्टिकल? सॉल्व किया तुम लोगों ने नेक्स्ट प्रैक्टिकल?